because we're moving on and the material piles up. So you don't want to postpone this till the end of semester, because I'm sure you will be busy enough with the other things, with your finals and so forth. So anyways, last time we looked at section 4.4, right, page 207. So to get there, I'll add 30, so it'll be like 237. So it looks like I skipped this a little bit, but anyways, we're here. And then I asked you to find mean. There was a little quiz, right? We had formulas for mean and formula for standard deviation. So I just asked you to find a mean for sample in exercise number 1. So in exercise number 1, here on the page 232, you look at the product of 400 and 0.2, and when you multiply these together, you get something like 80, right? So that's simple mean. Nice, straightforward little formula that makes people feel good. There's not too many formulas look so nice. I also can find the standard deviation. That's already not the question for the quiz. It's something else. It's just another formula that we saw in that section. So I'm gonna put in the square root 400 and then multiply it by 0.2 and then also multiply it by 0.8, actually by 1 minus, right? So Q could be found as 1 minus P. So if they gave you the fact that P was 0.2, then you subtract 0.2 from 1 and get 0.8. So that's how I put this 0.8 here. And use a calculator, of course, because calculator is definitely needed here. So how to use a calculator? We'll type a scientific calculator. Once you start typing it, after all these advertisements, very first choice, Desmos is here. So you can plug in 400 and then times this by 0.2 and then times this by 0.8. So we produce the standard deviation, which is 8. So we used to find mean and standard deviations in order to better describe our samples. So it looks like I want to find where's my book here. So we actually asked in this exercise to look at the mean and 2 standard deviations. So they decided to go from 80, which is a center, which is a mean for this distribution, to move to the right by 8 and then do this once again, and then you get 88, and if you add another 8, it'll be 96, right? And also you can subtract 8 twice. So if you subtract 8, it'll be 72. And if you subtract another 8, it'll be 64. So why we do this? Well, because they want to find these intervals. So I just answered the question to this set of exercises. So, oh, we didn't have a quiz. Okay, thank you for telling me. So I guess I started talking about section 4.4, but we didn't have a quiz, so thank you for reminding me. But anyways, I'm talking right now about the section 4.4. So last time, I think we had plenty of story in section 4.3, and 4.4 continues logically the ideas in there. But thank you so much for remembering this. So our ballpark for possible probabilities that people can calculate will be from 64 through 96, because those are reasonable numbers. If you got 400 element sample, and the chances that you get a success is only 20%. So, well, 20% of 400 is 80. That's what we expect, but it may be a little bit less or a little bit more. And that's exactly what a standard deviation utilizes. So you're right, we didn't really see these formulas as of yet, but I hope that when you looked at these formulas, you notice they're pretty intuitive, especially the formula for the average, which is a product of N and P. So maybe what I can do is return back to section 4.3. If you have any particular questions in mind, please let me know. And what I will do is go for the probability to find. And then I will also use these formulas to justify this a little bit better. So maybe that will be making us feeling nicer. So let me try something like one of the exercises from your homework. Let's say exercise number 31. In this exercise 31, the odd numbered problem wants us to deal with a TV show. There is some type of a TV show called 60 Minutes, if you are familiar with it. It has a share of 20, means that it's 20% on time. 20% of people who turn on TV watching this show. So probability that someone is watching the show called 60 Minutes is 0.2. Okay, so we have a chance that somebody is watching it. So they consider the total of 10 households here. So N is 10 number of households here. So question part A says, what's the probability that none of people watching this show? So I'm looking at exercise 31 from section 4.3. So what I do is look for the probability of 0 people that watch this show. And to be able to find such a probability, I need to recall the formula that we used in that section. It's P of X, which is a combinations N choose X multiplied by P raised to the power of X, and also multiplied by Q raised to the power of N minus X. So it looks like I need to know Q, the complement of P, which is 1 minus P, right? So this is going to be 0.8, looks like, just like in the previous example, very popular value. So if I replace X with a 0, then we go with combinations. N is 10, select 0 successes, multiplied by P, which is 0.2 raised to the power of 0, and then multiply by Q, which is 0.8 raised to the power of 10 minus 0. Remember, we used this formula, and we now going to see the answer here. So let me put this all in the calculator. So I hope you already remember that to get combinations, I need to go to functions, right? The lower row here. And now I return back to main where all the numbers are. So we go 10, comma 0 in the parentheses. And then we times this by 0.2 that we raised to the power of 0. And again, I bring this cursor down on the ground and times this by 0.8, which is raised to the power of 10 minus 0, which is just number 10. So we've got the answer. This is about 10%, right? 1073, dun, dun, dun. Is this a good chance or not really? Well, 10% is not high, so it may not happen. In fact, if I now use my mean and standard deviation formulas from next section, I think we'll see what we actually do expect to get when this experiment takes place, when the chances to find someone who watches the show is 20%. So I take out of 10 people 20%, and this is going to be 2. So we actually expect 2 people to watch the show, but it may be a little less or a little more. So we can find the ballpark, which is a standard deviation. So I can multiply these 3 numbers, 2.8 P and Q and 10. And then we're going to, of course, put this inside the square root. Maybe I can clear this a little bit. It's just too messy. So P is multiplied by our sample size. So I go square root 10 times 0.2 and then times Q, which is 0.8. So our standard deviation is 1.2 something, right? So once you found mean and standard deviation, then you can see what is actually expected here. So 2 people may watch it, but you may extend it to 3.26, right? On one side, because I add 126. And on the other side, I subtract 126. So it'll be like 0.74, I guess. So we actually expect that under these conditions, we're going to have either 2 people that watch show, or 1, or 3. And 0 is out of the ballpark. So 0 does not have high enough probability, although it may happen that we have a 0 as well as 4. But most likely we find that 2 people watching this show, or that 1 person or 3 will be watching this show. So let's go back. Looks like this exercise has more little questions, such as part B that says, what's the probability of at least 1? Oh, remember, that's one of our favorites. Probability of at least 1 is 1 minus the complement, right? At least 1 is watching the show is the same as 1 minus probability that none of them or 0 people watching the show, right? So when you subtract from 1 probability, which is 0.1073, well, you get a 0.8927. So here's the approximate result. I want to stress once again that probability has a special law, that all the probabilities are in between 0 and 1. So if you're taking the exam and some people give me the answer, they say, Alex, probability is 6. Well, this is not possible. Probability is in between 0 and 1. And I would say some instructors get so mad that they just give 0 on the whole final or the whole midterm because of this. Well, I'm not that kind. I just take it easy, but it's definitely very incorrect when somebody, after we've been with this probability for a while, still tells me that probability is bigger than 1, or if it is negative. All probabilities are percent. So like 10%, 90%, it's always in between 0% and 100%. So there is no way that you get probability outside of range, it means right away something is wrong. So when you be on the exam, you don't want to put such a number as the answer, because it tells your instructor that you probably need to take it over again, this whole thing, because you missed the key point, the start of exam. The reason I'm talking about it, because I still have some people that asking me, they think they did perfectly when they produce probabilities bigger than 1. It's actually supposed to be a failing grade for the test. Well, I was in a good mood, so I gave you some points, but and I also give a chance for some people to fix this, right? I told that you can work out the exam and to get a little bit higher grade. And I just received another test from someone, and that's great. So I will definitely take a look at it, and then I will update grades. But I will update grades in a few weeks, because first of all, it takes me a while. Just want to tell you, because some people expect that I update grades. Well, every time you send me something, right away I stop doing anything I do and start updating those grades. And this Blackboard program is very annoying. In order to update grades, I have to delete everything and then re-enter grades for the whole class. And it takes a while. So just because of one test that you submitted, I'm not going to delete all the class scores, which is over than 30, and re-enter all of them just because of one test. I do this, but I do this every few weeks, because next hour somebody else may send me something else, and I'll have to redo this again. And this way, since I have 6 classes, I'll have to do nothing but re-enter grades into the Blackboard. So please understand that you should wait a little bit. In fact, you can always ask me to see what your new grade is, and that's fine. You can always put the question in the Zoom chat. I have those grades with me. I can tell you right away. But this Blackboard is really nothing to do with the actual grade of yours. I have my own records. I calculate grades, and then I will enter your grades into totally different, the college website. So in the college website, at the end of semester, there'll be your grade. But this Blackboard thing is just a matter of me sharing your grade with you. So don't worry, whatever's on the Blackboard is not what the college will receive. Actually, it will eventually, but first, of course, you have chances to fix it, to work it out, and so forth. What actually concerns me at this stage, that some people still sending me their midterms, saying, Alex, something happened, a glitch in the building, internet, some box was stolen, all kinds of stories. So I understand that it's important that you don't fail the class because of some kind of outside circumstances. And that's why I think I should give the final exam earlier. Because if I wait for another 2 weeks for some people to finally submit me their finals, I don't have such a luxury. Because if I give you the final right before the due date, when I have to enter your grades, if I have 5 or 6 or 10 people that never sent me their final because of whatever reasons, I don't want to give them bad grades simply because of some of those glitches. So I started to think that I have to give you a final probably a week prior. So this way we'll be on the safe side and nothing will happen with these grades, because that's kind of odd, because this didn't happen last semester. For some reason in the spring, everything was on time. And now in my pretty much every class, I'm having a number of people that have issues sending me their midterm exam. I understand something is going on. I'm not blaming it on you. I'm just saying that I really need to be careful, and I guess just to give a final a little earlier, because I don't want to fail or give a D grade to someone just because I didn't receive the final by the moment when I have to enter those grades into the college website, because I also have my own deadline. They'll tell me don't enter it after that particular day, so I must do it before. And that's why I think I should have your grades earlier, so this way you will have a chance to get a good grade on class. And my goal is to help you with this, and you should realize, because I get a feeling that some people still thinking that I'm the one who's given bad grades on purpose. Well, maybe you also doing something totally wrong. I just made an example with probabilities bigger than 1, and I got so many people giving me such an answer. So there are some other mistakes appeared on the midterm exam. So I understand that things happen, and I do give you a chance to fix it, but please realize that we can always work on something. So instead of just bugging me, asking me, Alex, give me better grade, you give me better, well, maybe you should do something else. Maybe you should do some statistics. I don't mind to give you better grade, because to be honest, it's just a waste of time if you just keep telling me the same thing again. And if your test is wrong, then what can I do for that? Maybe you should do some extra credit problems instead of that. And that's what I keep saying, just do extra credit, even problems. In these sections, especially in section 4.4, I don't think it'd be very difficult to do the extra credit. Just look at this section 4.4, like exercise 2, for example, I just did 1. Exercise 2, it's a nice exercise. Exercise 4, so you can do a couple of problems and you already have a fix of your grade. And it's going to take you, what, 10 minutes to do these problems? It's not hard. You just should realize that, yes, I can spend extra time grading, or if you don't like these exercises, we can always discuss and see what else can be done in order to improve your performance. But again, it has to be on your side, not just on my side, that I regrade wrong exam. It's not going to bring you any better grade. But if you actually sit down and do a little bit of statistics, that's going to be beneficial. And the same is true, I believe, for any class, because most of instructors in our college are very helpful. So if you want to get a better grade, you can always ask if there's some project you can do. I'm open to just about anything. You want to do project and statistics, you want to do something else, just let me know. At the end of class, we can talk about this, and we can always come up with something that will work the best for you. And as I said, I'm still waiting for some people to submit me their midterms. See, there's still some people that never send me their midterm, even though I just ask, and I keep asking to send it to me, because otherwise you'll just get 0, and that's definitely no good. So anyways, enough with that. I'm sure that most people in class understand this and already sent me their work, and I was very happy with that. So anyways, let's try another exercise here. Let's say, how about problem number 5 that says guessing the answers. So it says that several students are not prepared for a true-false test. That's a 50-50, right? So probability that one will guess is 1 out of 2 questions, actually 1 out of 2 possibilities. You say either true or false. So out of these 2 choices, 1 of them is correct and the other is not correct. So P is probability that somebody guessed it correctly, and Q is that the answer is not correct. So it's 50% for P and a 50% for a Q. So 50-50, right? I hope you can see it's 50-50. So number of questions is 10. So in exercise number 5 here, I'm back to section 4.4. So in exercise number 5, there are 10 questions. And the question is mean and standard deviation. So mean is NP, and the standard deviation is square root from NPQ. So this is a pair that we, well, calculate using formulas. You just need a little calculator. The first one, I'm sure you can do without a calculator. It's 10 times 2, which is 20, so it's just 0.2, so it's 2. And for the second, I need a calculator for sure, because I have to extract the square root. So I multiply 10 by 0.2, and then again, I multiply this by 0.2, and then try to extract the square root from it. So let me get this calculator. So the square root I extract from 10 and times it by 0.2, and then times it by 0.2 again. So there is some number. Please notice you can't really guess this number. Look at the answer, 0.63. How would you be able to intuitively find it? Just get a calculator. Calculator is free, and for those people that joined us a little later, I can share the link to this calculator with everyone here in the Zoom chat. I think this is very helpful calculator. In fact, next chapters, we will see that without this calculator, it will be hard to solve problems, because problems will have a little bit bigger things to calculate. So anyways, we found the answers to this part of the exercise. It's actually part A. We found mean and we found the standard deviation. So then they want to see what about part B that says at least 7 correct answers. So to pass, people need to get C or better, right? And C is like 70%. So if you got 70% or 80 or 90, then the person passed. So it looks like second part is a question, how about get that many correct guesses only based on your mean, which is 2, and the standard deviation, which is 0.6 something, 3, 2, dot, dot, dot. So notice that it'll be like 2.6 approximately in one direction, and in the other direction will be like 1.4. So that's the ballpark that we expect. So the person will guess somewhere in between 1 and 3, roughly speaking, right? So how about 7? Well, looks like it's just too far from reality. Maybe you will guess 1, maybe 3. I say maybe 4. Well, maybe 4, but definitely not 7. So if somebody say, would this be unusual? The answer is, of course, yes. It'd be unusual that you guess so many correct answers. Because again, what we expect is 2 or maybe 3 if you be lucky, maybe 4, but definitely not 7. 7 is way, way too far from this ballpark, which is again based on your standard deviation and mean. So you can make an estimate by using these formulas. And the good thing about using these formulas is that actually they're pretty compact. So I can try another exercise here, and then maybe you can try one. So let's say, how about problem number 12 that talks about M&M candies? So problem number 12. And again, I'd like to put the link to the textbook here in a Zoom chat, because I got a feeling that some people don't have this textbook as of yet. So let me put this link, and I just saw a question in chat, so I can answer it definitely. So I think I was not correct. That's why I got this wrong, because it's actually 0.5. You're absolutely right. See, you're already better than I at this calculations, because indeed, the P and Q are both 0.5, right? So how did they get 0.2? Well, I have no idea. Maybe I look at the previous exercise. So the actual number here is 5, right? And then when I multiply this by 0.5, and I multiply this by 0.5, so let me change this. So it was noticed that it's actually 0.5, not 0.2, so I wasn't careful. So anyways, let me go back to the calculator. You could just highlight these previous entries and change them, so it'll be 0.5 and then another 0.5, right? Okay, so 1.58. Okay, so standard deviation. Let me cross it out because I wasn't careful. 158 something, 50, not 80, 58. So it's different numbers, so maybe I better erase because otherwise this is just too messy. So we have analogous picture, but a little bit different numbers, right? So we need to be placing correct numbers. So 5 is the mean, and then 158. 158. I said 8 and put 6. I have issue with 8 today. So this is 8. So if you go by 158 to the left and to the right, the actual largest value will be 658. And the smallest value will be 4.32, something like that, right? Oh, that changes everything, right? Because it looks like they're different numbers. So anyways, if you're just guessing in this multiple choice test, then 50-50 in a true false, it's not multiple choice, it's true false. So you're expected to guess how many questions? Well, looks like you expected to guess 5, or maybe 6, it's also here, or maybe 4. 4 is also possible. Can you guess 7? Is it possible? Maybe, because it's actually close to 7, right? So it's kind of on the border though, but it is possible that somebody who is a lucky guesser will guess 7 correct, and somebody who is not lucky guesser will only get 3 correct, right? So probably that's why people like true false tests. Well, you don't get them, many of them in a college. Usually we have multiple choice, right? So that way it's harder to guess, but true false indeed is possible to guess. So I should be careful. That's the, I guess, idea. So anyways, let me try an exercise with M&M candies, and I appreciate that you are double checking this, because it looks like you can miswrite one number and the answer will be totally different, right? So you better be concentrated, don't miswrite numbers. So anyways, back to number 12. They say that 10% of M&M candies are blue. Okay, so let me write it down so I don't forget that. Probability that some candy is blue is 10% or 0.1, right? So find mean and standard deviation if there are 100 candies. So if sample size is 100, then I can find mean, my favorite, right away, n times p, which is going to be 10% of 100 candies. So it'll be 10, right? So when I multiply these two numbers, I expect 10 candies to be blue. But of course, it's not always going to be 10. We already know it. So it's square root from NPQ. So I need a Q in order to find the standard deviation. So Q is going to be 90%, right? So 10% of candy is blue and the rest is not blue. So 90% of candy is not blue. Okay, so let us calculate standard deviation. So multiply by 0.1 and I multiply by 0.9. So I should do this carefully. So let's do this. Square root. right? Are you calculating this also? Times 0.1. I just gave you a link to this calculator in the chat, so you can get this right away. You get 0.948. So roughly speaking, about 1 candy, right? So we have here 948 dot dot dot. 8 dot dot dot. So I would say it's approximately equal to 1. So let me double check. What you are saying is that we have not 100 candy. They say group of 100. So 100, right? So it's 100 candy. So usually you buy a little bag and there's like 100 candies in this bag. So anyways, so it looks like we found mean, which is 10. We found the standard deviation, which is about 1, right? So maybe by 1 candy, there'll be off. So if you happen to not get 10 of these blue M&Ms, but just 9 of them, well, you don't have to sue that Mars corporation because they gave you 1 less blue candy. Take it easy. Maybe you'll get another package next time and you will get 11 in it because it may vary by 1. So I guess that's what it is. Part B is talking about data sets, so you don't have to worry about this part B because we don't have appendix. It says here that only 5 are blue. Well, is something wrong with that? Well, looks like the answer definitely yes. Something is wrong because the blue ones can be 10, right? And the favorite picture by standard deviation to the left. So it'll be like by 1 approximately. So it could be 11 or 9. But if it's only 5, then definitely not enough blue candies. So that's our exercise number 12. So let me give you a little quiz, and someone wanted to talk about me about the test. So definitely we should do this. I always like to clarify anything that is unclear, especially related to the tests. The only thing I cannot discuss over emails is grades, why this is so, but we can always do this in class. So how about if you try to do problem number 2 for a quiz, just find a mean, which is NP, right? So for the quiz for today, I don't ask you for a standard deviation. You could just find a mean, and that should be good enough for exercise number 2. As usual, put this in the chat, and then you can relax and leave. And if you want to talk about whatever to me, you can definitely discuss